Alright, so here we're going to look at pages 3 and 4 of the factoring packet. If you've come this far, hopefully you are feeling very comfortable with pages 1 and 2, because it's about to get a little bit more difficult as we move forward. And here is why. When I look at this first one, you might recognize, oh hey, there's a number with my x squared. Can I divide everybody by 2? And you'll realize that you can't. Alright, so on this page here, all of the numbers that are sitting out front are going to have to stay. Alright, they're not going to have any GCFs on this page. So here's what that means. It's going to be a little bit more complicated to get these factored out. And it's not just x times x anymore, because I have to get a 2x squared. I'm going to need a 2 right there. Another reason that makes this complicated is because the relationship that used to exist of numbers that multiply together to give me c that add to give me b will no longer be true. Now it has to be a unique combination of factors of c still, so I am still going to be looking for the factors, but it has to be those factors that also multiply by a's factors and then add to give us b. Alright, and really the best way to do these is to try a couple, check your answers with distributing, and then you'll kind of start to see the relationship that exists. Alright, now on this one, we couldn't really mess it up if we wanted to, because with that being a 1, I've got a 1 and a 1. Alright, I'm going to make it positive and positive. And let's check this to see how this would in fact be my answer. We'd get a 2x squared. We'd get a plus 2x. Here we'd get a plus an x. And then here is our plus 1. And these right here would combine to give us a 3x, which takes us back to our original expression of 2x squared plus 3x plus 1. Alright, so it does check out. Now, let's just look at several more of these to kind of get used to it. On this one, the only way to get 2y squared is going to be 2y and y. Alright, and then I see I'm looking for factors of a 3. So I'm going to go positive and positive here to get that positive 3 that will ultimately add up to get that 7. But here's the issues. The factors of this are 1 and 3. I need to decide which one goes where. Is the 3 going to go there, or is the 1 going to go there, or kind of switched around? And so you just kind of have to manipulate these until you find that scenario. Now I'm trying to get to 7. So what I'm going to recognize is, hey, if I could get this 2 and this 3 to multiply together, that gets me to 6. And then I could have the 1 and the y to complete that 7. So I'm going to put my 3 there. And I'm going to put my 1 there. All right, and that's how this one has to be set up. It would not be correct if you did this. If you put your 3 there, you would not get the right answer when you double check it. And there is only going to be one right answer for all of these. Alright, and let's double check this one to continue to grow in our ability to see. So we've got 2y squared plus a 6y plus a y plus a 3. That'll simplify down to 2y squared plus 7y plus 3, which is our original statement. Alright. So then as you get more and more comfortable with these, you'll start to be able to interact with the various positives and negatives here. So for example, on this one, I know I'm going to have a 2b and a b. Now when I see this positive 5, I know to get positive 5 through multiplication, these are either going to have to be double positive or double negative. I know that they're going to be double negative in this case because I need everything to ultimately add up together to give me a negative 11. So now I'm just messing with factors of 5, so I got 1 and 5. So with me needing to reach 11, I'm going to want this 2 and 5 ultimately to multiply. So I'm going to put the 5 there and the 1 there. And if you FOIL this out, you would get right back to that original statement. Alright, now these are definitely a little bit more complicated than the ones on the other page. Especially when this first number has a couple different factors to it. Alright, and here's what I mean by that. Here's some potential setups here. This could be 12y and y. However, we don't know. It could also be 4y and 3y. Or it could be 2y and 6y. Right? There's a whole bunch of different combinations, and it's a little tricky to sort through all of that different stuff. The more you do, though, the reason we're doing so many of these, the more you do, the better you will get at it. Luckily here, the factors of 1 are only 1 and 1. And so then, if you look at that, you're kind of just trying to visualize of multiplying this out. How can I get a negative 7? And you might recognize, hey, if I do negative 1, that this will, in fact, FOIL out all the way to give us our correct answer. And let me prove that here. If we take 12y squared, here's a minus 4y, here's a minus 3y, here's a plus 1, to take us back to our proper original statement. All right, so that is my answer. Now, how did I find that so fast? Well, I've done probably a couple thousand of these over the course of the years. And so the only way to get better at these and faster at these is to do so many of them. But this will save us a whole bunch of pain come chapters in Algebra 2 when we factor a whole bunch. All right, so I'll do one more here before I move on to the next page. So once again, what could this be? It could be a 6a and an a. All right, could be a 2a and a 3a. I don't know. We need to just kind of check both scenarios until maybe we can find the combination that we're looking for. All right, so issues on this one, though, is with 24, I've got 1 and 24, I've got 2 and 12, we've got 3 and 8, we've got 4 and 6. So a lot of different combinations to cross-reference with the multiples of 6, which are 2 and 3 and 6 and 1. A lot of different numbers to keep track of, but you will get faster at these the more that you do them. So after cross-referencing for a while, also factoring in that I'm going to need one of them to be positive and one of them to be negative, here's what you might conclude. I'm going to put a plus 3 here. And over here I'm going to put a minus 8. All right, so here's how, at least for now, this potentially could be an answer. All right, here's how I know. This is kind of the preliminary steps to check. Well, 2a times 3a gives me a 6a squared. Positive 3 times negative 8 gives me a negative 24. So all that's in place. Now I just need to make sure that when I multiply these out, so I get a 6a squared, I get a minus 16a, and then here I'll get a plus 9a, and then I get a minus 24. Here's something to keep in mind. Notice what happens on my answer. 6a squared, I end up with a negative 7a, but I was looking for a positive 7a. If this happens, you are very, very close to finding your answer. Here's the only thing you're going to need to do if you realize that you wanted positive and you received a negative. That means you need to go back into your problems. The only thing you're going to need to change there are these two signs. All right, if I go back and take care of that, if I come back here and make this one negative, and this one positive, here's how this will change when I multiply this out. It would make it a positive 16a, a negative 9. That way when they combine, I end up back with the right answer, thus making this correct. Okay? So with these, they're going to take you some time. You're going to be foiling out a lot of answers, finding a lot of wrong combinations. You just have to stick with it. The more you do, the faster you'll be able to get at it. Okay? Solving with these works the same way as the other page. First step is to get them factored. This one has to start off 5x and x, and then it has to have a 1 and a 1. All right, so there's that one. I'm not going to go through the process of verifying it. That one is correct. We would take the same pieces as we did on the other page, set them up equal to 0, and solve. So for here, I then have 5x is equal to a negative 1. So x is equal to a negative 1/5 is one answer. And then on this one here, I would subtract a 1 from both sides and get that x is equal to a negative 1. All right, so that's the process of solving. You still just factor it into its two pieces and then set both of those pieces up equal to 0 and solve for x. All right, page 4. I'm only going to do a couple of these here. It's going to be similar to the last page. And that's going to be where we are ultimately going to have a number with our x squared. But this page there will be GCFs. All right, so looking at number 1, I'm looking for what number can I divide all of these by? And that number is a 2. So that would bring it down to a 2x squared plus 3x plus a 1. Now, the benefit of pulling out the GCF, the greatest common factor, is that now all I have to factor is this. That's going to be easier because finding the factors of 4 and the factors of 2 and cross-referencing, there's going to be more options for that one than there would be using just a 2 and a 1. So that is your motivation to check to see if there's a GCF. And now our answer would look like this. The 2 that we took out, he's going to stay there. And then now I'm just factoring my highlighted portion, which would be a 2x and an x plus 1 and a plus 1. There's my answer. And you could FOIL all that out to double check. Okay? So on this one here, right below it,